Hello dear students. So in this video, we will be discussing electrostatics PYQ from April 2024 attempt. If you like our video, if you find this video valuable, do consider to press the like button and subscribe to our channel, right? Let us start with our video. Yeah. So let us start. The first question that we have, it is your 4th April shift 1 question. Let us look at the question. An infinitely long positively charged straight thread has a linear charge density lambda coulomb per meter. Let us draw the situation. So let's say that a long thread is there having charge density lambda coulomb per meter. Well and good. An electron revolves along a circular path having axis along the length of a wire. Fine. Length of the wire. This is our wire, long thread, and along this a electron is moving in circular path. This is the situation given. Fine. The graph that correctly represents the variation of kinetic energy of electron as a function of radius of circular path from the wire is. Let's do. So beta, they are asking us the relation between graph, that is the graph between your kinetic energy and radius, this distance from the wire. How to do it? Let's say that the electron is over here. This is the electron which is moving in circular path, right? At a distance or in a radius of r. If electron is moving in circular path, that means some force will provide the necessary centripetal force. Which force will provide? This long wire will be producing an electric field, and this electric field will be radially outward. From this it will be radially outward. Charge density is positive, right? So because of this electric field, the electron, the negatively charged electron, will experience a force opposite to electric field, that means radially inward. So over here your force electric is like this, right? Now this force electric is, how much force electric value we can write it? Force electric is Q into E, which is basically E into E. How much is the electric field produced by your long wire? Electric field is 2K lambda by R. So our force electric becomes 2K lambda by R into E. This is the electric force. This electric force provides the necessary centripetal force, right? I'll do over here. So what can we write? Force electric is equals to force centripetal. Force electric 2K lambda by R into E is equals to force centripetal. Centripetal force is M into V square by R. Fine, well and good. Let's see over here. If you notice carefully, we can do this. R and R will cancel out basically. So 1 by 2, 1 by 2. This term, this is our kinetic energy. This is our kinetic energy. So kinetic energy comes out to be K lambda E. Kinetic energy comes out to be K lambda E. If you notice carefully, kinetic energy is K, our Coulomb's constant, 1 by 4 pi epsilon naught, which is constant. Lambda, charge density constant. E, the charge on electron. Kinetic energy is a constant. It does not vary with R. Now you look at the 4 options that are given. Option number, if you see, option number 2. In option number 2, the kinetic energy is constant, right? So our answer will be option number 2. Let us move ahead. Yes. So the second question that we have, it says an infinite plane sheet of charge having uniform surface charge density plus sigma s coulomb per meter square is placed on xy plane. Let us draw the situation. So let's draw the situation. This is our coordinate x, y and our z. There is a sheet which is along your xy plane, which is in xy plane. I'll take it over here. Let's say that this is our sheet in xy plane. Charge density is sigma s coulomb per meter square. Fine, well and good. Next it says another infinitely long charge line charge having uniform linear charge densities lambda, right? It is, so that means lambda is placed at z equals to 4 meter. Z equals to 4 meter plane and parallel to y axis. That means this is our y axis and z equals to 4. If we draw it, it will come something like this. See carefully. What is the, it is present in, or I can say that it is passes through this point 0, 0, 4, right? Okay. If the magnitude value sigma s is equals to 2 times lambda, sigma s is equals to 2 times lambda. In magnitude terms they have given us. Then at point 0 comma 0 comma 2, the ratio of magnitude of electric field values due to sheet charge to that of line charge is electric field due to sheet by electric field due to line charge. This is given to us as pi into root n by 1. You have to find out the value of n. Let us do. So this is a line wire, this is our sheet. It's a infinite sheet, large sheet basically. Okay, it's a large sheet, and they are asking us the electric field at this point, which is 0 comma 0 comma 2, right? Let's see. Electric field due to sheet. What is the electric field due to sheet? Due to an infinite sheet, it is sigma by 2 epsilon naught, right? Due to a thin infinite sheet, it is sigma by 2 epsilon naught. Fine, well and good. Due to this line wire, how much we can write it? Due to line wire, 2k lambda by r. 2k lambda by r value. How much is r? The distance of the point, the perpendicular distance of the point from this line wire. It is your 0 comma 0 comma 2. That means the distance is 2, right? 2 units. So we will get it over here. 2k lambda by 2 cancels out. Lambda is given to us as basically sigma by 2. Lambda can be written as sigma by 2. So 1 by 4 pi epsilon naught into sigma s by 2. This is our electric field due to line wire coming. Let us take the ratio 1:2, right? If we take the ratio, ES by EL is equals to sigma s by 2 epsilon naught into sigma s into 4 pi epsilon naught into 2. What are we getting? Sigma s cancels out, epsilon naught cancels out. We have 4 pi is the answer coming. But if you check it, what it is given? Pi into root n. That means this can be written as pi into root 16. That implies our n value will come out to be 16. Answer for this question is n is equals to 16. Let us move ahead. Yeah. So a third question that we have, it says a charge q is placed at the center of one of the surface of a cube. Fine. Let us draw the situation. A cube is there and the charge is placed at the center of one of the surfaces. Any surface you can take it. Let's say that I take this top surface, the charge is placed over here. They are asking us the flux linked with the cube. Let's see. We can do this question with the help of Gauss law. What does our Gauss law say? Phi is equals to q in by epsilon naught. Now this is not, the charge is not present inside the cube. It is present on one of the surfaces. So can we draw a structure such that this charge, q charge, gets enclosed in a closed surface? So for that, what we will do is, we'll consider another cube at the top of it, right? Identical like this way, right? Now if you notice carefully, this q charge which was on the surface, when we have considered another cube at the top, now this charge comes symmetrically. It is placed symmetrically with respect to these two cubes. So the total flux produced by this charge in these two cubes will be how much? It will be q by epsilon naught. Identical cubes are there. That means how much will be the flux through the lower cube? It will be, phi will be equals to q by half of this, q by 2 epsilon naught. Right? So this will be our answer. You can check the option. The option will be your second option, q by 2 epsilon naught, right? Let's move ahead. Yeah. So the question we have, it's a theoretical question. The vehicle carrying inflammable fluids usually have metallic chains touching the ground. What is the reason for it? If you check from, let's see, bottom, if we see, it's a custom. To protect tires from catching dirt from ground, doesn't make any sense. To alert other vehicles, no. To conduct excess charge due to air friction to ground and prevent sparking. Yes, due to air friction, there is a possibility that charges can accumulate in that and it can cause some fire, right? So therefore the answer for this is your option number 1. So such that the charge can move through the chain to the ground. This is whole process. Reasoning is right. Let's move ahead. Yeah. Our next question, it's a dipole question. Let's see. The electric field at a point P due to electric dipole is E. The diagram is there in front of you. P point is an axial point. P is an axial point at a distance of R. What is the electric field at axial point? Electric field at axial point is 2 kp by r cube. I hope you know the result. So electric field at axial point is 2 kp by r cube. The electric field at point r on equatorial line will be E by x. So r point, it's an equatorial point and it is at a distance of 2r. So first of all, what is the electric field at an equatorial point? It is kp by r cube, right? We should know the result. Electric field at equatorial point is kp by r cube, but this r, the distance of the point is 2r. In the diagram it is given to us. So kp by 2r whole cube. How much we are getting? Kp by 8r cube, right? Now let us see. So they are asking if this value is E, then E by x, fine. The value of x is, let's see. Basically both the results are there in front of you. Let's solve it. So kp by r cube is nothing but your E by 2 is equals to kp by r cube. I'll put over here, this is electric field on the equatorial line. So I can write it, this kp by r cube is E by 2. So E by 8 into 2, that implies E by 16. If we compare it with the value that is given to us, that is E by x, that implies x value will be equals to 16, right? Let's move ahead. Yes. So let us see. The question is there in front of you. Diagram is also there. Check it. Three infinitely long charged thin sheets. These are charged thin sheets are placed as shown in figure. The magnitude of electric field at point P is x sigma by epsilon naught. The net electric field due to these three sheets is x sigma by epsilon naught. Fine. The value of x is. Now if you notice carefully, the sheet, that is the left one, right? The leftmost sheet, it is having charge density minus sigma. That means electric field will be towards the sheet. The second sheet, it is, that is the one which is having the charge density minus 2 sigma. It will again negatively charged sheet, that implies the electric field will be towards the sheet. The third one, that is the rightmost, right? For point P, it is rightmost and it is a positively charged sheet, that is plus sigma. So obviously the electric field will be away from the sheet. That implies electric field direction is in the same direction, that is towards negative x direction for all of them. And what is the magnitude of electric field? Magnitude of electric field due to a sheet, due to a thin sheet, is given as sigma by 2 epsilon naught, right? And due to all the three sheets, it is towards negative x direction. Electric field due to a sheet does not depend on the distance. Due to a long sheet, it does not depend on the distance. It is constant and it is given as sigma by 2 epsilon naught. Now let us write down. So E net can be written as E1 plus E2 plus E3, right? I am going from this side, 1, 2, 3, right? So E1 will be sigma by 2 epsilon naught, E2 will be 2 sigma by 2 epsilon naught. I am writing the magnitude part only over here. Direction we have discussed. Due to all the three sheets, the direction will be towards basically negative x. Sigma by 2 epsilon naught, 2 sigma by 2 epsilon naught, and third one will be sigma by 2 epsilon naught. If we add all of these, we will get it 4 sigma by 2 epsilon naught minus I cap, because negative x direction. Ultimately what we are getting, 2 sigma by epsilon naught. If you compare it, your x value will come out to be over here minus I. So your x value will come out to be 2. Our answer is x is 2, right? Let's move ahead. Yeah. So the question that we have, let's read the question carefully. Two identical conducting spheres P and S with charge Q on each repel each other with a force 16 Newton. Let's draw the diagram. So two spheres, identical spheres P and S, right? Let's say that their centers are at a separation of r. This is our assumption, nothing is given to us in the question. So let's say that their centers are at a distance of r, right? They are each having a charge of q. The obviously charge is identical, so they will be repelling. And how much is the repulsion force? 16 Newton. So what can we say? F is equals to k q into q, that is q square divided by r square. This is equals to 16. This is what is given to us. Fine. Next it says a third identical uncharged conducting sphere r is successfully brought in contact with the two spheres. That means one uncharged sphere r successively brought in contact. First it is brought in contact with P and with your after S. Next, the new force of repulsion between P and S is. Let us see. So this R is also identical, that means size wise it is same only, but it is uncharged initially. It is uncharged initially. So first it is brought in contact to P. If it is brought in contact to P, whenever you have identical spheres and when they are brought in contact due to your conduction, right, due to your charging by conduction, the charge will get distributed equally. The charge will get distributed equally. So total charge on this q 0, total charge on the system is your q, it will get equally distributed. So how much it will be? On P it will come q by 2 and then on R it will be q by 2. Now this R is brought in contact to S. Let's see. Next step, this is S having charge q, R which is having a charge of q by 2. How much is the total charge on them? The total charge on them is q plus q by 2, that is 3q by 2. When it is brought in contact, whenever two identical spheres are brought in contact, the charge will get equally distributed, identical. So the charge will get equally distributed. So 3q by 2. So on S, you will get 3q by 2 by 2, which is 3q by 4. And on R, you will have 3q by 4. Ultimately, what we are having? On P, the charge is q by 2. On S, the charge is 3q by 4. Fine. Let's see now. So on P, q by 2 and on S, your charge is 3q by 4. Again, they are asking us the what way, how much the force becomes. What is the change in the force, right? That is what the, if we go to the language, the new force of repulsion between P and S is. Fine. So when, let's say, let's write it, new force is F dash. F dash will be equals to K charge on P, which is q by 2, charge on S, which is 3q by 4 divided by R square. What can we write it? 3kq square by 8r square. 3kq square by 8r square. What is our kq by r square? That is given to us as 16. So we can write F dash is equals to 3 by 8 into 16, 2 times. F dash value comes out to be 6 Newton. The new force between the two spheres will be 6 Newton. You can check the option, check options are there, right? Let's move ahead. Yeah. So our next question, it says, two charge conducting spheres of radius A and B are connected to each other by a conducting wire. So let's say this is A, radius is A. Let's say initial charge is Q1 and another sphere having radius B, initial charge is Q2, right? This is what they have given. So two charge conducting spheres of radius A and B are connected to each other by a conducting wire. The ratio of charges of the two spheres respectively is. So when this will be connected, that means when they are brought into contact with the help of the conducting wire, what will happen? Charge distribution will take place. What is the concept over here? The concept is that charge distribution will take place till the time the potential of the two spheres will become same. The potential of the two spheres becomes same. So let's say that the charge over here becomes small q1 and the charge on this one comes out to be small q2. Ultimately, potential, the charge distribution will take place till the time the potentials become equal. So finally V1 will be equals to V2. What can we say about the potential of this? It can be written as k q1 by A. Potential of second, it will be KQ2 by B. If we look at the final charge ratio, Q1 by Q2 will be equals to A by B. So our answer is, the ratio of the final charges on the sphere is A is to B. Let's move ahead. Yeah. So the question that we have, it says an electric field E is equals to 2I cap plus 6J cap plus 8K cap by root 6. So electric field is 2I cap plus 6J cap plus 8K cap by root 6 passes through the surface of 4 meter square area having unit vector n cap equals to, so the area for this is, magnitude of area is 4 meter square, and the having unit vector n cap equals to 2I cap plus j cap plus k cap, n cap equals to 2I cap plus j cap plus k cap by root 6. Fine. The electric flux for that surface is dash voltmeter. Electric flux. What is our flux? Flux we write as integral E dot A. It is integral E dot A. If electric field is constant, we can write down electric field as E dot A, E vector dot A vector, right? A vector is basically, the A vector magnitude is 4, but direction of A vector is your perpendicular to the surface, and the unit vector which is perpendicular to the surface they have given us. So what can we write the relation E over here? 2I cap plus 6J cap plus 8K cap by root 6 into area vector 4 into this unit vector. So 4 into 2I cap plus J cap plus K cap by root 6. From here you can see root 6, 6 and 4. We can take this out. 4 by 6. Further, if we do the dot product, it will come out to be 4 plus 6 plus 8, which is 4 by 6 into 18. So flux value is coming out to be 12 voltmeter, right? It comes out to be 12 voltmeter. This is our flux. Answer 5 value is 12. Let's move ahead. Yes. So let us see. The question that we have is, it says, if the net electric field at point P along y-axis is 0, then the ratio of Q2 by Q3, the magnitude of Q2 by Q3 is 8 by 5 root x. That means Q2 by Q3 magnitude is 8 by 5 root x. What is the condition given? That electric field in y direction, the net electric field in y direction is 0, है ना? Electric field in y direction is 0. Fine. Where x is? So the diagram is there in front of you, है ना? This is the situation that is given to us. Let us see. This is Q2, positive charge. Electric field due to positive charge at point P, away from the charge. This is, I am calling it as E2, due to charge Q2, electric field E2. Minus Q3, due to a negative charge, electric field is towards the charge. So minus, due to this, it will be over here. Let's call it as E3, right? They are saying that the y component of electric field is 0. Y component, so let us say that this angle, basically y component, that implies the vertical components of both of this. For that, we will have to write down the vertical components. Let us first define the angles. So beta, over here, let's call this as angle as Q2, theta 2. Let's call this angle as theta 2 and this angle as theta 3. And just for the Q2, Q3 is given in question, that's why I am taking theta 2, theta 3. Fine. So over here, this is Q2. If you notice carefully, if this is Q2, this angle, not Q2, theta 2, again and again Q2, Q2 is coming to my mouth. Basically theta 2, the angle is over here theta 2, this angle is theta 2, so this angle will also be theta 2, vertically opposite. This is your theta 3. Now let's look at the vertical components. What is your vertical component of this E2? It will come out to be your E2 cos theta 2, right? What is the vertical component of your E3? It will come downward, and how much it will be? It will be your E2 cos theta 3. If we want that net electric field in y direction is 0, that implies the two components in vertical, they should be equal in magnitude. Direction wise we can see they are opposite, है ना? So we can write down E2 cos theta 2 is equals to E2 cos theta 3. Right now, with the help of direction only, I wrote down these. Now let us look at the magnitude part. Electric field due to second Q2 charge at this point P. Electric field due to a point charge, what do we write it? We write KQ by R square. KQ by R square. R is the distance of point from the charge. If you notice, this is 2, this is 4. So this one distance will come out to be root 16 plus 2, that is your root 20. Over here, this is 4, this is 3, right angle triangle, this will become 5. That means the distance of point P from minus Q3 is 5. Let's see, electric field due to 2 at this point, how much it will be? K Q2 divided by R square, which is 20 into cos theta 2. Cos theta 2 will be what? This triangle. If you focus on this triangle over here, this triangle, cos theta 2, we can write it as adjacent by hypotenuse, which will be your 4 by root 20. This is equals to E3. This will be E3 beta. I have written E2. This will be E3. And the electric field due to your minus Q3, it will be E3. How much is your E3 value? K Q3 by distance square, the separation square, which is 5. So 5 square, 25 into cos theta 3. Cos theta 3, if we notice this triangle, in this triangle, adjacent by hypotenuse, adjacent is your 4, hypotenuse is your 5. Fine. Let's see. K cancel, 4 cancels out. Ratio of Q2 by Q3. Q2 by Q3 can be taken as 20 by 25, 20 into 20 root 2 by 25 into 5. Right? This Q2 by Q3 magnitude is given to us as 8 by 5 root x. Let's simplify this. Cancels out. We have this over here 4 times. This is 5 times, 4 times, 2 times. Let's take it this side. So we have over here root x is equals to 10 by root 20. Root x is equals to 10 by root 20. Therefore, x is equals to 100 by 20. That implies x value is 5. So our answer is, the x value is 5. I hope the solution is okay. First of all, we looked at the direction of electric field. We found the vertical components for both of them, and then we equated the vertical components. Let's move ahead. Yeah. So the question that we have, it says, at the center of a half ring of radius r equals to 10 centimeter and linear charge density 4 nano coulomb per meter. So half ring is there. Okay. Radius is r, which is given to us as 10 centimeter. Lambda value is given to us as 4 nano coulomb per meter. Fine. The potential is x pi volt. Over here at the center is x pi volt. This is what is your potential given to us, right? Let's see. So they are asking us the value of x. The value of x they are asking. Now beta see, this is a half ring at the center. All the points are at equal distance from the center. For a ring, the center will be equidistant. So potential, what can we write? Potential will be simply kq by r. Potential due to half ring at its center is kq by r. Let's see. Q is not given to us, but charge density is given to us. We can write it, q will be your lambda into pi r. Lambda into the length of it. So lambda into pi r divided by r. What we are having? R and r cancels out. K value. How much is our k value? K is 9 into 10 power 9. Lambda is given to us 4 nano coulomb per meter. So this one I can write it as 4 into 10 power minus 9 into pi, right? 4 into 10 power minus 9 into pi. This is what we have got as our potential. This, if we simplify 10 power 9, 10 power minus 9 cancels out. We have 9,4 is 36 pi. 36 pi is our potential coming. If we compare it with our value, your x value will come out to be 36. Right? What was given to us? V is equals to x pi. So with that we get your x value as 36. Let's move ahead. Yeah. So the question we have is, it says 5 charges plus q plus 5q minus 2q plus 3q and minus 4q are situated as shown in figure. The electric flux due to this configuration through the surface SS. Right? Diagram is there in front of you. What does our Gauss law say? Flux is equals to q inside by epsilon naught. Right? If you look at it carefully, how much charge is enclosed? What is the charge inside? Plus 5q, q 6q minus 2q, that is plus 4q divided by epsilon naught. So our flux is 4q by epsilon naught, option number B. Option number B is our correct answer. Let's move ahead. Yeah. So with this question, we have reached to the end of our video. This is the last question. Let's see what it says. An electric field E vector equals to 2x I cap Newton per Coulomb exists in space. So electric field is 2x I cap. Okay. A cube of side 2 meter is placed in the space as per figure given below. Fine. The electric flux through the cube is dash Newton meter square by Coulomb. Let us see. So electric field is in x direction. It is in x direction. Like this, the electric field lines are there, right? You can see this. I hope the marker is clear. I'll draw with black. So this is what is given. Electric field lines are towards positive x. Now, if you will notice that the flux will be only defined for this surface and for this surface. Why? Because for all the remaining surfaces, I am talking about the top surface, bottom surface, the back surface and the front surface, the area vector is perpendicular. Electric field is positive x, area vector for the top surface will be y direction, 90 degrees. Angle between electric field and your area vector is your 90 degrees. What is our flux? Flux we write as E vector dot A vector. And now flux is E dot A. For constant electric field, we can write down E vector dot A vector. Over here, obviously, electric field is not constant. But at any x, that means at x equals to 2, at x equals to 4, we can say electric field is constant, right? So, at x equals to 2, at x equals to 4, electric field is constant. First thing. Second thing, electric field over here is along positive x direction. Area vector will be coming upward. For the bottom surface, it will come downward. So it is 90 degrees angle, EA cos 90. That means flux will be 0. So only we need to calculate flux due to the surface where it is entering and this surface where it is exiting from. So E net, let's call this as your phi 1 and this is your phi 2. Right? What can we write it? Phi 1 plus phi 2. Remaining, the flux due through remaining all surfaces will be 0. Okay, phi 1, how much we can write it? Electric field. Electric field at x equals to 2. How much it will be? 2 into 2, 4 into area. Area will be your how much? It is given to us 2 meter. So area will be 2 square and cos theta. Angle between them. Electric field is towards positive x, whereas area vector will be outward. And for closed surface we take area vector outward. So this one will come out to be cos 180 plus phi 2. How much it will be? Electric field at this distance comes out to be 4. So 2 into 4, that is your 8 I cap. So this is 8 into area again is your 2 into 2, 4 into cos 0. Because the area vector for this one will be outward like this, right? Let's see how much we are getting. 4 into 4 cos 180 minus 1 plus 34 into 1. We get over here minus 16 plus 32. This comes out phi net is equals to 16. The net flux through the cube is 16. So our answer will be 16 for this, right? I hope this is okay. So with this we have completed our video. I hope you found the video helpful. Do consider to press the like button. and subscribe to our channel. Also, you can check out our other PYQs video. We have done PYQ for kinematics, Newton's law, work energy power, then your ray optics, right? You can check all these PYQ videos also. Thank you very much. Bye bye.